All right, guys, so we're gonna get started. This is page 36 in your interactive notebook. All right, so we're gonna start off here. We're gonna go over some basic things for inequalities. So we're talking about systems of inequalities. And so before talking about systems of inequalities, we're just gonna clarify some quick little things here. So remember, this is your less than, and this is your greater than. Agreed? And this is less than or equal to, and this is greater than or equal to. Yes? All right, so here we go. Step one is you want to solve each inequality for y. Now, notice here on the first equation, I subtract 2x, check, right? Then right here, this is a special situation. I have to divide by a negative. So when you divide or multiply by a negative, it changes the signs. And it's not just the signs of the terms, it also changes the inequality. So notice how my inequality went from being greater than to less than. So when you multiply or divide by a negative, it's going to change the signs. So my -2 became a +2, my +1 became a -1. And so this is my equation now. Okay. All right. On the second equation, it stayed the same. All right. The next thing is to graph your boundary line. And there's a couple things for your boundary lines that we're going to pay attention to. For your boundary lines, if your boundary lines are what do these things called? Strictly less than or greater than, then you're going to have a dotted line, a dotted or dash, whatever you want to call it. If your boundary lines are less than or equal to or greater than equal to, you're going to have a solid line. Okay. Then we're going to talk about shading. So if you're going to shade, if it's less than, we're shading below, not above. We shade below. If it's greater than, we shade above. So that's how that table works, okay? So when we come over here and we look at our first line, it says that we have y is less than 2x minus 1. This tells us everything we need to know. I have less than, strictly less than, so I know I'm going to be below and I'm going to be dotted. Do we see that? So I'm going to be a dotted line and I'm going to be shaded below. And then everything else is normal stuff. Here's my slope and here's my y-intercept. So I go to -1 and follow my slope, rise 2, run 1 to the right, rise 2. And notice how it's a dotted line or dash, whatever you want to call it, and not a solid line. Yes? Okay. And we're going to shade below. So shading below the line, I do squiggles because this pen is too much. So shaded below the line. Now let's look at equation 2. So equation 2, when we got y by itself, we were left with y is greater than or equal to -x plus 3. What does this inequality tell me? Dotted or solid? It is solid because it's equal to. And above or below? There's the one whisper, above. Why is it above? Because it's greater than. Do we see that? Here it tells you my slope is -1 and my y-intercept is b. Do we see that? So I start at 3, but it's -1. So I'm going down 1 and then right 1 all the way down. And notice how this line is solid because it was equal to. And I'm going to shade above the line. So I'm going to do my squiggles above. Okay. Your solution is where they overlap. So in your bag, you should have highlighter, but where they overlap is your solution. Your solution also includes the piece of the solid line that's there, because solid means also equal to. Okay. So to test that your shaded region is correct, if you choose any point within this shaded region, you should be able to plug into that system and it should make true statements. So for example, if I choose 3, 1 right here, 3, 1, is that in my shaded? So I'm going to use 3, 1, which means that X is 3 and Y is 1. So if I put this into the system, the original system gives me 2 times 3 minus 1 is greater than 1. And then 2 plus 1 is greater than or equal to 3. So notice I plugged in where X was, I plugged in 3. Where Y was, I plugged in 1. 6 minus 1, is that greater than 1? Yes. 2 plus 1, is that greater than or equal to 3? Yes. So that lets me know that the shaded region is my solution. Okay. This is just for checking yourself if you are not confident that your area is correct. Terrible. So step 1, we isolated the Y. Step 2, we drew our boundary lines. Step 3, we shaded. Cool. All right. Let's do one from the beginning. So step 1 is make sure Y is isolated. Is Y isolated? Yes. Step 2 is to graph. So we're going to graph. And we have Y is greater than or equal to X. I just needed more space. What does this tell me about the line? Good job. Solid. What does it tell me about my shading? It's below. Okay. And this is my parent function, right? Slope of 1 and goes through the origin. Boom, boom. I like graphing. I was concentrating. All right. And I'm going to shade below. Makes me feel like a calculator. There's no always, because there's so many different variations, right? You still are. All right. There's my shading. Okay, how do we feel so far? So now we're going to do the second equation. So the second equation, I know that based on this, greater than or equal to, what kind of line? And what kind of shading? There we go. Okay, my slope is 3 and my starting is -1. Do we see that? So I'm going to go to -1. I'm going to rise 3, 1, 2, 3, and run 1, 1, 2, 3, 1, 2, 3. I'm going to reverse it, down 3 and left 1, 1, 2, 3. So it's rise 3, right? 1, 2, 3. And then we said it's a solid line, so I'm going to do my very best to connect all of these points. And we're going to pretend that Ms. Jones drew the straightest line ever. Yeah, she did. All right, and we said shaded above. So above this, squiggle, squiggle, squiggle. I mean, it's easier to shade if you're a paper, but it's a little funky on here. So I got to squiggle it out. Thanks.
Oh, wait, no, mine's ugly.
All right, where do my squiggles meet? So in quadrant 3, you see where this triangle is? That is my solution.
Also, like, the answer on the test would be.
Just the shaded region. Because that's your answer. Okay. So if I wasn't sure, what would I do to check my answer? What do we say? If you're not sure, then you choose any point in that shaded region, right? And see if it works. Okay. So for example, if I chose -1, -2. Oh man. Thought it wasn't working. If I chose -1, -2, and I plugged into the original system, I would have -2 is less than or equal to -1. Is that true? Yes. Then I would have -2 is greater than or equal to 3 times -1 minus 1. That is also true. So what does that tell me I did? Everything right. Still with me? All right. If you can do 3, you can do anything. Okay. So I'm going to do it, but I encourage you to go ahead if you feel comfortable. But if you can do 3, you can do any of them. Does that make sense? So 3 is our tying it all together. So from beginning to end. So the first thing we need to do is get y by itself. So we have 2x plus y is greater than 3. We subtract 2x. And we get y is greater than -2x plus 3. On the other side. Okay. And then we're going to get the next equation by itself. So we have x minus y is less than 2. We subtract x. We're left with -y is less than -x plus 2. Uh-oh, what's going to happen? I'm dividing by a negative, and what is that going to do? It changes the sign of everyone. Negativity affects everything. Is that not a fact? That is a fact. Okay, so step 1 is to get your y's by themselves. How do we feel about step 1? Okay, step 2 is we're going to graph our boundary line. What is the boundary line for the first one? What's going to be? What kind of line am I going to have? I'm going to have a dotted, and then what kind of shading? Above. Are we cool? I'm going to go to 3. I'm going to go down 2, right 1, down 2, right 1. Why am I going down? Because it's negative. I'm going to draw my dashes. All right, and I'm above. So squiggle, squiggle, squiggle above. Above or below the line. All right, on our second one, what's happening? What kind of boundary line do I have? Dotted. What kind of shading? Greater than. All right, so I'm going to start at -1. And my slope is just 1, so up 1, right 1. Put in my all right. And we're going to shade where again? Above. Can we clearly see where they overlap? So we already see our solution space. All right, so our solution space is the triangle that's in quadrant 1 and quadrant 2. How do you feel about coloring today? Not terrible, right? All right. Okay. So 4, I want you to do 4. You're going to work 4 with your table mates. All right. So for this one, you should have started at -1. And your slope, it's down 1 and then right 3. Maybe. Okay. And it should be a dashed boundary. And it should be shaded below. So that's what you should have gotten for the first piece. And then your second piece should have started at +1. And then you've gone up 3 and right 1. And then reverse it. 1, 2, 3. 1, 2, 3. And then it's also a dash. It's solid, not dash. I knew that. And it's shaded above. And you should be in quadrant 3 and a little bit of quadrant 2. Bye. Good luck on the PSAT tomorrow. All right. Say it again. Good. Yeah. Nim. I don't think there's. All right. Boom. All right. So that's what it should look like as your solution. Good job.